and really just visibility, honestly, in general. So this makes sense, right? We have firewalls that protect our internal networks from the internet. We have firewalls in a branch design that can also protect kind of the branch's internal network from maybe different parts of the network across the campus or branches, and from the internet as well. Some reasons why we think we do a particularly good job in this use case, and we'll get into this in a second, I believe, in this section, is we have some really cool frameworks we've developed to give you visibility into the applications and enforcement of those applications without having to encrypt traffic. And expand a little bit on that. Traditional methods that firewalls from all the vendors use to determine applications are falling short now because they relied on certain parts of the traffic to be decrypted. Either the whole session to be decrypted, or at least some of the packet headers. And we'll get into it a little bit under the hood in a little bit here. But TLS 1.3 has been kind of a game changer for the worst for visibility, because some of that initial handshake that we relied on as a firewall or a proxy to see what it was all hidden now. And again, that's great if I'm sitting at my coffee shop and I don't want the person next to me snooping on my banking or something. But it's a challenge if I'm an enterprise trying to get visibility in. There's a few things you can do when you have encrypted traffic everywhere, right? The seed packet inspection, as it turns here, is now challenged. We can decrypt traffic. That's expensive because I either got to buy a beefier box to do that, or I have to buy specialized hardware to wrap around my firewalls and proxies and different things to do the decryption. Many sites actually will break if I decrypt. So I rolled out decryption at my last company, which was a 20,000 person company, and we spent about a year rolling out our decryption just to make sure nothing catastrophic happened. And I'm glad we did that because there are many things that break when you decrypt. And you got to tune those, right? If you tune it all and it's all perfect, then of course it works fine, so to speak. But there's a lot of challenges. In some environments, I'm imagining some of you are universities, maybe. If you're like a university, for instance, like you can't decrypt your student traffic because now you have to convince them to put a CA from the college on their laptop. And if I was a student, I probably wouldn't do that, right? So effectively what you do otherwise is you just break all their internet traffic. And then there's privacy concerns too, right? Are we allowed to peer into the student's traffic? What if we accidentally decrypt the wrong thing and now there's a legal issue, and there's a lot to consider. So this actually goes into some of that. We have a new concept called TLS Server Identity Discovery, and this came out in 6.7. I believe it was called Early TLS Discovery or something like that. It's in the advanced section of access control. And the very, very recent build, it's now a subsection of the SSL policy selector. But, this is kind of what traffic identity or discovery looked like for a firewall or proxy in pre-TLS 1.3 days, so TLS 1.2 or earlier. This is kind of what that handshake is, right? You have a client hello packet with a server name indicator. You have a response from the server. Server hello, server certificate, server hello done, and then you have your application data starting to flow within TLS. But these initial packets up here, which I believe this is actually more than just two, I think this is just showing you the direction. These packets were all decrypted at the beginning, and there was a lot of rich information in there that a firewall or a proxy would use to determine what I need to do, how I need to categorize this, what application is it, what URL is it, what domain is it, so I can determine what I need. Within TLS 1.3, I believe it's after the client hello, if I'm not mistaken, everything else is now essentially encrypted. So all of this rich data is now hidden from me. And if you don't turn on any of these new features and you look even on your FMC, or if you have a Fortinet or a PAN or a check, whatever, right? You'll see that the URL visibility is really, really bad now. And the application discovery is really bad. Again, I'm not privy to every vendor, so I would hope that all the vendors are trying to think through this right now. But using the old tool sets that have been around for years just doesn't work anymore. And you'll see very generic things like application tagged as SSL client. Well, yeah, because everything is an SSL client if we don't know what it is. So anyway, long story short, if you check this box to turn on the TLS server identity discovery, does not do decryption, what actually happens under the hood is the firewall will see that client hello. That is still unencrypted from the client. I'm TLS 1.3. I would like to do TLS 1.3, please. Client hello packet. We know that this is going to start off a TLS 1.3 session. So what the firewall will do, if we turn this on, is it will actually open what we call a sidecar TLS 1.2 connection to the same server. So we essentially replicate that client hello packet, except it's now coming from us, Mr. Firewall, and it's going, and we can only talk TLS 1.2. So this all happens right in like milliseconds. But the FTD will essentially pause this initial client hello, will not let it through. It will send its own TLS 1.2 version of that client hello, but replicating the source as being itself. The server will reply back, right, because the firewall is trying to make a connection. And since it's TLS 1.2, and since the firewall is the client in this little sidecar connection, it sees all that data that was missing now in TLS 1.3. I now know what server it's trying to go to. I know what server certificate it's giving me all of these data points I now see, just like I did back in TLS 1.2 days. I will now terminate this sidecar connection several milliseconds later, and I will now, if my firewall policy allows that connection, I will now pass through that original client hello that I had paused and allow it to continue uninterrupted from there.
So what's going to happen when the servers start turning off 1.2? Which isn't there
yet.
Yeah,
it's going to be probably a long time before that happens. I can't predict the future. Presumably that we'll have other things, or that people innovate, right, as new challenges arise. So, and we'll talk a little bit about some other things we're working on that don't even require this in a second too. So, yeah, it's a whole new world with this. And just to be clear, this is not going to be perfect compared to what TLS 1.2 was. I would say it gets you about 70% of the way there. And what I mean is sometimes this server is maybe load balancing 100 different sites, right? On a content delivery server or something like that. The initial data that it gives back is going to be maybe generic to some extent. So I still can't see the GET request that the client's making. That's all in the encrypted payload. So again, it's not perfect, but this is definitely something worth checking that box. And I've done kind of A/B testing. You get dramatically more info. And generally, if you're doing like URL-based categorization and stuff like that on the firewall, it gets you pretty close to exactly what you were doing before. Because even if it's a CDN hosting a bunch of sites, it's going to be in the same type of category, that maybe that individual site was. And it gives you a lot of extra data that's useful for our application ID engine as well.
Does it by any chance coordinate with DNS lookups that might resolve to that?
So there is a DNS feature. I don't think we covered it here, and I actually can't remember what version it came on in, but there is a feature in the firewall, and again, I don't have a slide, and the details super fresh in my mind, but where if we see an A record request and we see the response, we can then, for a kind of cached period of time, correlate that if we see a URL request to the same IP. That assumes a lot. In a lot of networks, the client-to-server DNS request is not something that a firewall maybe sees. So that's not broadly applicable everywhere. But that is something we've done. I want to say maybe since 7.1 or something like that, we rolled that feature out. And I don't even think that's an on-off switch. It's just a data point that the firewall uses now. That was a good question. And yeah, for those of you that maybe are using Umbrella and handling URL type policy there, I mean, that's a great solution because DNS is still a simple kind of plain text A record request. We have stuff like DNS over HTTPS to combat, but there's ways to pretty reliably handle those scenarios. And I don't see a future in the foreseeable future where DNS, the whole model of DNS kind of inherently goes away. So that is, of course, another option kind of beyond the scope of the firewall directly, but for sure. Encrypted visibility engine is the other thing I wanted to talk about. This is a pretty amazing feature. This is an expanding feature. Every single version we've been developing, this functionality has expanded. It's actually based on an open source project that I believe Cisco developed. It's on GitHub called Wormgear Engine. But we branded encrypted visibility engine. The first experimental version, and actually it worked just fine. We just called it experimental, and as out of an abundance of caution, was in 7.1. It lost the experimental tag in 7.2. New features came out with it in 7.3, and even new features. I'm actually beta testing 7.4 at home, and there's some pretty cool new stuff it's going to do there that I unfortunately can't tell you about quite yet, but you'll hear about soon. At its core, the purpose of this engine is to give you additional visibility into TLS and quick traffic. Does anyone want to take a stab at defining what quick traffic is? Yes.
It's essentially the HTTPS over UDP instead of TCP.
Yeah, that's a pretty accurate description, right? So Google, if a little bit of history, Google determined that TLS was very wasteful in how it works. I would agree. And it's because it's chained to the TCP protocol, which has all these active packets, and there's a very regimented way that a TCP-based session has to work. So quick is essentially, it's almost like a lightweight variant of TCP logic baked into the UDP underlying protocol, which basically has no requirements and is kind of free form. That's a problem though, because a lot of firewalls don't know how to handle quick, other than that they know it's UDP 443. So while this also handles like TLS 1.3 and stuff, we also have some of that engine dedicated to quick and identifying quick servers and stuff like that. The core of this engine is machine learning based, and we mostly will we determine the application actually based on the client hello packet, which is the one packet that is still plain text. I can't explain to you the lines of code and how it all works under the hood. I can tell you that it appears to work very darn good. I've been running it for a long time, and I'm amazed at how well it can identify applications. The client hello packet, if you're running 7.2 or later, if we've determined with a high degree of certainty what application it is using that machine learning, we will also map it back to the primary kind of application field in your firewall logs. And that also means that if you have application-based firewall rules, the encrypted visibility engines insight into applications effectively is a detection source that allows your application-based rules to still function. Does that hopefully make sense how I describe that? I'm trying to do my best job of layman's terms there. So another thing that's cool is apparently an encrypted visibility engine has a core application database that's bigger than the app ID database that you actually see in your policies. It's pretty cool. I saw, for instance, as an example, I think this might have been the Roomba at our house, because I have an FMC at my lab is basically just my house. So the Roomba was identified, and I think it was the Roomba, but identified as SSL client by the traditional app ID engine, because it's all TLS 1.3, but encrypted visibility engine was able to determine that it was actually Python running on the vacuum and flagged it as Python with like an 87% confidence rate or something like that. So pretty cool. This is what I was trying to get to. If you have policy actions in your access control rule, allow, block, etc., the client application determines feeds into the same underlying engine that policy decisions in your firewall rules are made on. And then at the bottom, this is really cool, and we're continuing to enhance this, but we also identify the likelihood that an encrypted flow is malicious. So if anyone has heard of encrypted traffic analytics, which is a feature of our StealthWatch product, it's kind of similar to that. We look at the client hello, we look at some other contextual data, and importantly, we have a product called Secure Malware Analytics. It's also known as ThreatGrid. Anyone heard of ThreatGrid before? A few of you? ThreatGrid is a cloud-based sandbox that we manage. Our Talos Threat Intelligence group uses this almost exclusively for malware detonation and stuff like that. And if you are doing advanced malware protection as an engine in your firepower, if you're using it in Umbrella, if you're using it in our secure endpoint or AMP for endpoints tool, our email security tool, anything that connects with AMP that does dynamic analysis is using that cloud sandbox on the back end. So we have millions of malware samples being sent from customers every day. We have Talos delivering malware to it. That sandbox knows the network communications patterns of the malware samples that we see, right? That makes sense, where the sandbox, that's part of its function, is to look at the network communications. If we know what the malware is, and we know what the communications look like, we have essentially baked this in. We have a definitions list, essentially, that comes as part of the vulnerability database updates, where some malware isn't notable in an encrypted tunnel, but some of it is very distinct in how it communicates. And even though we can't decrypt your tunnel if you don't turn on decryption, we can still tell you with a certain degree of likelihood that this connection we just saw that was encrypted matches with a very high fidelity to this known malicious traffic. Does that make sense? So it's a way, without doing decryption in environments maybe where you can't decrypt, to get some insight into that traffic still. So this is trying to show you here an example. We have Firefox running on a laptop, and then we have Tor, which Tor runs on Firefox, essentially, on the laptop, at least by default. Communications, though, the client hellos look a little bit different, where they're going, so some of the contextual data looks a little bit different. And with the encrypted visibility engine, we can tell here, with 99.94% confidence, this is Firefox. Down here, 100% confidence it is Tor.exe running. Even though under the hood, otherwise, this will just be SSL client. The traditional engine would see. So there's another engine called JA3 that some of the other firewall vendors have adopted, and it's actually developed by Salesforce, which is pretty interesting. And it was Salesforce's in-house way to start doing SSL fingerprinting. So they were, I guess, as a customer, marketing the same thing. It's pretty crazy what Fortune 500s will do. That's outside of the normal wheelhouse. But anyway, JA3 you'll see it's in other products. It does do some stuff, right? I'd rather have that than nothing. There's a bunch of different contextual data that we grab. And the overall database of detected apps is, I understand, like 5-fold larger. We also are unique in that we have added support for QUIC. And we do have a way with pretty high fidelity to map a client hello QUIC packet to a domain. So you'll actually start seeing QUIC traffic will start showing URLs as well in your logs. All right. Speaking through encryption still, we do have integrated TLS 1.3 encryption enabled. I want to say this came out in 7.1. It's certainly there in 7.2. So traditionally, what a lot of firewall, and most of them have gotten to this point by now, but traditionally, a firewall or proxy would inspect TLS 1.3 by forcing a downgrade to TLS 1.2 and then inspecting it at that layer. We no longer need to do that, so we can keep it at the TLS 1.3 protocol, decrypt it, make our enforcement decisions, etc. So just to be clear, there is no special licensing for TLS decryption. This is considered part of the base license of the firewall product. And just since I mentioned that, encrypted visibility engine, we require the threat license, which is what, like IPS and security intelligence. Hopefully you already have that license subscription. There's no net new subscription for it. And then that early identity discovery thing I mentioned before, that is base license capable too. So none of these require like a special net new thing.